So this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and please participate. But please do not share contact info during class for your own security reasons or social media info for your own security reasons. All right, so please make sure again that your attendance check is open. Link is in the chat box along with the start of class word is there too. So if for some reason, I know a lot of us are having issues with K-12 right now, it's being really slow. So if that's the case for you, just write down what the start of class word is. That way you have it for later, and just make sure it gets done before midnight tonight. All right, go ahead and give me a rainbow if that makes sense. Rainbow if you understand, if that makes sense. Okay, so again, thank you, Nichelle. If you need to, just write it down and then make sure you submit it before midnight, because that's when it closes. Okay, remember, live class attendance is 10% of your grade, and you can only get it if you're actually attending class, so you got to make sure you are coming to class. All right, so we are, sorry, this should say day 3. I forgot to fill that in. We are on day 3 out of 45. Today we're talking about matter and energy. We're going to do some notes today. Now, again, the K-12 website is being super slow, so I wasn't actually able to update your notes. So today we're going to need to either write down the answers or take pictures of the answers, or once the recording is uploaded, you can just take a look at the recording again in order to get those answers. So I'm so sorry about that. I'll try to get it. It's just very slow, so I'm trying to update it slowly. So I'll try to get it up by 10:30 for you, but I apologize for that. I don't know what's going on with K-12 right now, but it took me forever to even get into the notes today. Okay, so we do have a required class today that you're in right now. We will also have an optional support, which I'll talk about in a moment. So again, today we have the 1C notes and attendance. Again, take pictures and then just try to get it done before midnight. It is in the chat box, Landon. Just look right underneath the link, and the actual word is right there. You can actually just copy paste it if you want. Cool. Hi, Vanessa. How are you doing? All right. So tomorrow we will have our first lab. Super exciting. This one, the data is actually already given for you. It's just you need to be able to analyze the data. So make sure you come to class. I'll take you through it step by step. Wednesday we'll be starting unit number 2. So already jumping into unit number 2. Hi, Micaiah. Good to see you. And then Thursday, we will have our first analysis. So I'll show you what that is. It's going to be a reading that you're going to annotate, analyze, answer some questions about based on your own thoughts. And then Friday, we will continue with our unit number 2. Okay. So some quick announcements. Again, I know most of you already, yes, exterminate, Landon. Do you like our costumes? This is what we were for Halloween. Isn't my daughter adorable? All right. So some announcements. I know most of you that I've already had already know all of this, but for those of you that are new with me, I want to make sure I go over this several times this week so we're just familiar with this and there's no confusion. So again, attendance is worth 10% of your grade. That's an Insight policy. You only get it if you're actually attending and participating in the live class. So you got to make sure you're coming here. Make sure you arrive on time. I only give out the start of class word for the first 15 minutes, and then make sure you stay to the end. I only give the end of class word after we're done with everything. Analyses, labs, and exams, those are your big assignments. There are 15 of them in total, right? 5 analyses, 5 labs, 5 exams. They're worth 65% of your grade, which means it's completely impossible to pass if you don't do them. All right, so you need to do all of them. All right, in order to pass, you need to do most of them well. All right, go ahead and give me a thumbs up if that makes sense. I do take you through every step, every question, right? So I do my best to break it down for you, but you have to actually meet me halfway and do the work. You got to put in the time, do the work. Again, it's only 15 big assignments, right? That's the majority of my class. All right. Again, Star 360 is 10% of your grade. Mr. Hargrave has been sending out emails with your username, password, and the website. Make sure that you get both reading and math assessments done, right? Remember, we have to do this every single quarter, and you got to make sure you do both of them in order to get full credits. We're 200 points in my class. You only get 100 points if you only do one of them. Now, remember, you want to actually do your best. Don't just fly through it. Actually do your best. Try to do it really well, because the better you do, the less required live sessions you have, and so your attendance is less affected. All right, go ahead and give me a lightning bolt if you understand. Lightning bolt if you understand that. Hi, Albert. Welcome to class. Please open your attendance check. Link is in the chat box. Start of class word is there as well. Perfect. Remember, make sure you're checking your grades tab every day. I am putting everything in the grades tab, links to everything, also your grades, obviously, feedback that you need. So make sure you're going to your grades tab every day. That's the most important location in my course. And then again, today we do have our first support session. So if you're confused about anything in my course, whether it's how do I get to stuff, how do I log into stuff, how do I do this, this, and that, or if you actually have questions on the actual material, definitely come to support. It's at 1 o'clock today. And it's going to be through Zoom. So how many of you are already familiar with Zoom? Give me a yes or no in the chat box. So Zoom is a website. It's a much easier way to meet with students. Yeah, okay, so it's a lot faster. So what you're going to see is that there is a Zoom link under your class plan box or under your plan tab. So it's on the actual course page. When it says support session, click on it, and it'll show you the Zoom link. All right, go ahead and give me a thumbs up if that makes sense. Just keep in mind, Zoom is just a lot faster to use, so it's really easy to just click on the link and then get to your Zoom session. So it's really fast. Just remember, it's not in Class Connect. It's actually on the course page. So it's the event on the course page. Click on that and you will see the link. Okay? It does change for every session, so you got to make sure you're clicking the right one. Perfect. All right, so we have been taking a look at Unit 1, Nature of Matter. So we're taking a look at how matter is classified, the nature of energy. In tomorrow's lab, we'll be taking a look at the concept of viscosity. So lots of really good stuff. So today we should be able to classify matter based on its properties and explain how matter and energy interact. Here is our agenda over here, and we will be completing the 1C notes eventually today. So normally I have you open up your 1C notes, but unfortunately my computer is so slow right now with K-12 that I wasn't able to get your notes ready. All right. So instead, what we're going to do is as we go through, I'm just going to ask you to take a picture or a screenshot or write down the answer, and then you'll give me a green check once you've done that. All right, so you can't access your notes right now. They're not open because there's nothing in it yet. But once it's opened, you can go ahead and fill that in. And I said I'll try to get it done by 10:30 today. Hopefully my computer works fast enough. All right, one last time, go ahead and give me a football if you understand. Football if you understand. I'm so sorry about that. I don't know what's going on with K-12. Cool. All right, if you're somebody that's watching the recording, just go to Unit 1, scroll down to the 1C notes, and then you can click Start Quiz. It's also in the Grades tab, obviously. Remember, I do give you all the answers for the notes word for word, so you don't need to make up any answers. You don't need to think about any answers. I'm just giving them to you. Cool. All right, so let's talk about how does matter get classified. So matter... Sorry, just one last time. That's the last time I'm going to send out the attendance check. Matter can be classified into either pure substances or mixtures, and then further classified, there are pure elements, pure compounds, and then homogeneous mixtures and heterogeneous mixtures. So first off, let's go ahead, either type on the board or in the chat box. I want to know what are some of the steps that you need to do in order to make spaghetti and meatballs. All right, think about making a really good dish of spaghetti and meatballs. What are some things that you might need to do? Like literally think about if I were to make spaghetti and meatballs right now, what would I need to do? Right, so we need to boil water. Why do we need to boil water? What's the point of boiling the water? Yeah, we need some tomato sauce, right? So we need to go to the store to what? Buy ingredients. Yeah, we're going to boil water. We're going to cook the noodles, heat them up. Yes. What about if I want to make the meatballs? What do I need for the meatballs? Tell me in the chat box. We're going to need some tomato sauce, which if you're going to make it, right, that's going to be cooking tomatoes, some onions, some garlic, right, some seasonings, salt and pepper. Does anyone wash their noodles before cooking them? I do not wash my noodles. There's actually a benefit to that because it actually creates what's called starchy water. And starchy water, if you add a little bit of it to your sauce, it helps it stick to your noodles better. Yeah, so we need meat, right? So for the meatballs, So for the meatballs, right, we're going to mix up some ground beef, right, or ground pork or whatever, some ground meat, right? We're going to add some more seasonings, right? So onions, garlic. We might add some breadcrumbs, are often used in meatballs, some eggs, for example, and then we need to roll them up, right? Roll them up with our hands. And then what do we need to do? Do we just eat the meatballs like that, right? We've combined everything together. We've rolled it up. Do we eat the meatballs like that? Oh no! There's a recipe for food poisoning if I've ever heard one. What do we need to do? Yeah, we need to either cook them in the oven, or pan fry them. Absolutely. Okay, so why are we talking about all of this? Well, we're going to see as we go through class today that when you're making spaghetti and meatballs, right, which is something you'll probably do at some point in your life if you haven't already, you're actually utilizing a lot of different things. You're utilizing things that are both like physical changes, chemical changes. You're going to be using things that are mixtures, using things that are solutions, right? So we're going to go ahead and talk about how does this relate to today's content. So just keep that in mind. We will come back to it. So let's talk about how matter gets classified. So remember, matter is just all the stuff around you, all the physical stuff around you that's made up of atoms, that has volume, that has mass, right? So mixtures are the first category. Mixtures mean that the components can be separated physically. Put them on a Barbie? What? Oh, like a grill, you mean? Yes, barbecue. There you go. I mean, Barbie is like what they would call it in Australia, but I was very confused for a moment. So I was like, I don't think a Barbie is gonna cook that meatball well. Yes, the UK, exactly. Mixtures, components can be separated physically. Now, there are two types of mixtures. The first is homogeneous mixtures, which we also called solutions. And thinking about this prefix homo, do you think this prefix homo means same or different? Tell me in the chat box. All right, when we use this prefix in science, what does this mean? Does it mean same or different? Homogeneous mixtures, what's that mean? Yes, it's going to mean same, right? So homogeneous mixtures look the same throughout. They're what's called uniform, meaning they looked exactly identical in every single spot. So this is, for example, salt water. So for example, with your pasta, right, oftentimes you add a little bit of salt into the water before you boil your pasta, and that salt water is going to be a homogeneous mixture or a solution. All right, but it can be separated physically, because what if you boiled your water to the point that there was no more water in the pot? What would be left over at the bottom? Tell me in the chat box. If you evaporated all the water, boiled it all off, what would be left at the bottom of your pot? Tell me in the chat box. Yeah, you would have the salt left over, exactly. So that's a physical process. Evaporation is a physical process. It's not a chemical process. And so you can physically separate out that water from the salt. So that is why this is still a mixture. They're separated physically, and it's homogeneous because it looks the same throughout. Now, heterogeneous mixtures, on the other hand, look different throughout. They are not uniform. So this, for example, would be like if you looked at a piece of wood, wood looks different, right? In some places, it might have knots. In some places, it might have bugs. In some places, it might have moisture. A cookie looks very different throughout if you take a look at this cookie down here. Or, for example, a meatball, right? If we think about our example that we took a look at it before, a meatball looks very different throughout. Yeah, so milk, real milk, like milk that has not gone through processing yet, milk you get from a cow, is heterogeneous because there's actually layers of fat at the top and then more liquidy stuff at the bottom. Go ahead, give me a thumbs up, everyone, if that makes sense. I know milk is always kind of an iffy one, but perfect. Now, pure substances, on the other hand, are what they sound like. They're pure, right? So you can't separate them physically, all right? So things like elements like oxygen can't be separated, are pure, so they can't be separated physically. Elements are also interesting, though, because they actually can't even be separated chemically, right? Yeah, no worries, Alex. Glad you were able to make it. So oxygen, right? You can't separate it either physically, right? You can't physically get different parts of oxygen apart, as well as you can't separate it chemically. Jelly, sorry, is that? Oh no, sorry. I'll tell you what number 1 is. Remember, always look for that bright yellow box, and I'll show that to you. And then compounds like sodium chloride, which is salt, can be separated chemically, but they can't be separated physically, right? If you were to break down a piece of salt more and more and more, you would still just have salt. The only way you could separate it is if you actually had it undergo a chemical reaction. All right. So let's break that down a little bit more. So again, mixtures can be physically separated without needing chemical reactions. So for example, you can crush a rock and physically separate out the minerals. Again, you can evaporate water from salt, and evaporation is just a physical process. It's not a chemical process. So heterogeneous mixtures, again, if you were to take a sample of all the different parts of the mixture, they would all look different. Think about raisin bread, right? If you get a sample from the crust, if you get a sample from the center, if you get the sample from a lower corner, it's all going to look very different. So if you take a look down here, right, on the left, this is a heterogeneous mixture. So if you took a sample from the top, that would all be purple, for example. If you took a sample from the bottom, that would all be green. And if you took a sample from over here, that would be both green and purple. So it looks different throughout. Remember, hetero means different. Hetero means different throughout. Go ahead, give me a magic 8 ball if that makes sense. Give me a magic 8 ball if that makes sense. Perfect. I guess it's not a magic 8 ball. I think I'm mixing two things together. Now, homogeneous mixtures, on the other hand, mean that if you take various samples throughout the entire mixture, they're all the same. And again, this is like salt water, right? If you take a sample of salt water from the top of a glass, from the bottom of the glass, from the middle of the glass, it all tastes the same. All right, go ahead, give me a thumbs up if that makes sense. Homogeneous mixtures, again, homo meaning same, so it looks the same throughout. Again, taking a look here, if you take a sample from here, right, it looks the same as a sample down here, which looks the same as a sample from over here. Okay. All right. So this will be number 1 in your notes. Again, I'm sorry, your notes aren't ready yet because of the K-12 issue right now. It's being too slow for me to edit them. But this will be number 1 in your notes, and you'll be matching these up. So you'll match up heterogeneous mixtures with its definition and homogeneous mixtures with its definition. Go ahead, give me a green check once you have a picture or a screenshot of this. You have 30 seconds. Again, sorry, your notes aren't ready, but you can take a picture of this so you can finish it later once your notes are ready. All right, I have 12 green checks so far, so that's about 50% of you. I need the rest of you participating. So Albert, Alex, let's see here, Alexis, Aliana, Twan, Estella, Jelly. Oh, sorry, Alex, you want to go by Junior, right? So Junior, go ahead, get me your green check, please. Looking good. All right, everyone. So that will be number 1. All right, so let me go ahead. I'm gonna show you really quickly a demo of this. All right, so let's go ahead and take a look at an actual example of how we could make a physically separate mixtures. All right, so let's take a look at this. All right, go ahead. Can you guys see my screen here? Perfect. All right, so I picked up my stuff. I'm going to enter. All right, so let's go ahead and take a look at this. So we want to go ahead and separate out some of these materials here. Sorry, I'm going to close this out really quick. There we go. Okay, so let's go ahead. Let's try to separate out the iron fillings. Okay, what do you think I could use in order to get the iron out of this mixture? Again, this is a physical mixture. We can physically separate everything in this mixture. So how do you think I could pick up the iron fillings? Tell me in the chat box. Take a look at this. We've got a beaker, a funnel, a sorry, what is this called? A filter. We've got a magnet. We've got another beaker with a stirring rod. We've got a hot plate. Yeah, with the magnet, right? Magnets are able to attract iron filings. Cool. So let's go ahead and get that. And let's see what happens. So the magnet is able to actually pick up those iron filings physically and then separate them out from our solution. Good. Now we also need to go ahead and figure out how can we get the, let's see here. Let's try the salt. Let's see if we can get the salt out of here. Actually, sorry, let's go ahead. Yeah, we can do the salt. All right. So in order to do the salt, what's that physical process I've been telling you about so far? What's that physical process where we can actually separate out salt water? The salt and the water together. What's that process called? Think back to our pasta pot. What would happen if we had boiled off all the water? What's that called? Starts with an E. Yeah, evaporation, exactly. So with evaporation, all right, let's go ahead. All right, let's go ahead and think about this. In order to make something evaporate, what do I need to first do? I need to first have what? Yeah, I need some water, right? I'm also going to need some what? I think I might actually want to, no. Okay, yeah. So we're going to need some water. We're going to need some, oh no, I am, sorry guys, one second. I definitely need to redo this, sorry. Let's go ahead and let's actually separate the sand first. I just realized that. I think I want to separate the sand first. All right, yeah, let's go ahead and separate the sand out first. I'm so sorry about that, guys. All right, so let's go ahead. Think about how sand, all right, is a much bigger particle than salt. All right, so again, salt will easily dissolve in water. So we're going to go ahead and grab this water. We're going to grab the funnel, and we're also going to grab the filter. All right, and also the beaker, I think. We need all of those. So what you're going to see is we're going to go ahead and actually take the solution, and we're going to dissolve it in some water. And what that will do is all the salt's going to go into the water, but the sand does not dissolve into the water. Go ahead, give me a thumbs up if that makes sense. So the sand does not dissolve into the water. And so when we filter it, the salt water goes through the filter, but the sand stays outside of it. So the sand stays outside of it. And so now we have that sand, and we can go ahead and separate that out. So sorry, now we can go ahead and do the salt. All right, so let's go ahead and take a look at our salt here. So again, you guys were right. We need the hot plate in order to heat this up, right? And then let's see here. Is that everything that I want? I think that's everything I want. No, let's see here. Let's go ahead and get the beaker too. There we go. So now we're going to go ahead and we're going to pour the salt water into here. We're going to put it on our hot plate, and we're going to evaporate it until there's no water left. We physically separate out the water, and all that's left is salt. All that's left is salt. Go ahead and give me a telephone if that makes sense. Telephone if that makes sense. Right, so there's our salt right there. So all of those things were physical processes. We were physically able to separate things out with a magnet, physically able to separate things out with a filter, and physically able to separate things out with a process called evaporation. Perfect. All right. So let's go ahead and talk a little bit about pure substances. So pure substances, again, cannot be separated by physical means. So you cannot physically like rip apart a water molecule, for example. All right. So pure substances cannot be separated by physical means. So for example, compounds are chemically joined or bonded together. So even though they might be made up of different elements, they're not actually mixtures, right? So they're not mixtures of hydrogen and oxygen, for example. Water is two hydrogens actually bonded to one oxygen, and you cannot physically rip apart water. All right, go ahead and give me a thumbs up if that makes sense, right? I don't know how many of you have ever tried this, but you can't just go into water and try to physically rip it apart. It's not going to happen, okay? Now, compounds, again, are pure substances that you can't break down physically. However, they can be broken down chemically. So water, for example, can be broken down chemically, which would actually break the bonds. It can also be formed chemically, right? It's actually formed from hydrogen and oxygen reacting together with fire, right? You need a spark, and they will actually react together to create water, okay? Hi, Hallie, welcome to class. How are you doing? All right, so elements, on the other hand, are pure substances that can't be broken down physically or chemically. So remember, compounds can't be broken down physically, but because they're made up of different types of atoms, like water is made up of hydrogen and oxygen, you can make them undergo a reaction, a chemical reaction, to break them apart. Elements, on the other hand, are completely pure. They're pure both physically as well as chemically because they're only made up of a single type of atom. All right, again, go ahead, take a picture of this. This is going to be number 1 in your notes once your notes are ready. Again, if you just joined us, no worries, Hallie. If you just joined us, the notes, I wasn't able to edit them because K12.com is not working for me right now. But I will try to get them uploaded by 10:30. Hopefully the website works a little bit faster and I can do that. All right, so go ahead. I'm going to give you 30 second screen checks once you have a picture or a screenshot of this and you're ready to move on. Again, just take a picture or write it down. That way you're ready to fill out your notes once your notes do open, and it'll be really fast. It'll only take you like 5 minutes. Green checks, everyone. All right, waiting on some more green checks. Let's see here. Junior, Alicia, Amaya, Ari, Chris, Danny. Let's get a green check. Hallie, Jarrett, Julian, Micaiah. Looking good. All right, everyone. So if you take a look here, this is the periodic table of elements. We're going to have an entire unit on this, so you will learn a lot about this. But these are, for example, all of the pure things that you can't break down either physically or chemically because they're all their own atoms. So for example, hydrogen is its own atom, helium is its own atom, oxygen and carbon, right? We've got neon up here. You can see copper, silver, gold. What else? Krypton, for those of you that are Superman fans. We've got potassium, sodium, calcium. Let's see here. What other ones might you be familiar with? Silicon. phosphorus, sulfur, chlorine. So all of these right here, for example, guys, are things that are actually their own atoms, and they cannot be anything simpler. If you tried to break them down, remember, if you try to break down atoms, you cause explosions. All right, and then it's no longer that same thing. It no longer has its identity. All right, go ahead and give me a house, if that makes sense. Go ahead, give me a house emoji if that makes sense. I want to make sure everyone understands this. So these are examples of completely pure, both physically and chemically. Cool. All right, so go ahead, match these up on the board for me. We've talked about homogeneous mixtures. Again, think about the prefix homo. We talked about heterogeneous. Think about the prefix hetero. And then elements versus compounds. Grab your whiteboard tools. Please use thin lines, any color but red, and match those up with their examples. All right, so we've got a cookie, we've got salt water, we've got copper, and then we've got sodium chloride, which is made up of bonded sodium with chlorine. All right, so think about, is that an element or a compound? Copper, is that an element or a compound? We just looked at the periodic table. Perfect, perfect, perfect. All right, let's see who we've got on the board. Awesome. I see Hallie, I see Aliana, I see Amaya, Andrick, Nichelle, Ari. Awesome, lots of participation. All right, can't see anymore. Good. All right, let me go ahead and pause these tools. Looking good, everyone. And let's shrink these down a little bit. Perfect. All right, so homogeneous mixture. Yes, homogeneous means it is a mixture that looks the same throughout, like salt water, but it can be physically separated, right? So you can physically separate salt from water using the physical process of evaporation. Heterogeneous mixtures means it looks different throughout. So think about our meatball, think about a cookie, right? If you took different parts of the cookie or the meatball, they would all look different from each other. And you could physically separate them out, right? You could physically separate the onions and the garlic from the meat in a meatball, or the chocolate chips from the crust in a cookie. An element like copper is an element. It's the most simple thing. It's a single atom, and it cannot be simplified either physically or chemically. No worries, David. And then compounds, right? Compounds are bonded atoms together. So sodium bonded with chlorine. Can't break it down physically. You can't physically break apart a salt molecule, but it can be broken down chemically. All right, so this will be number 2 in your notes. David, you just joined us, so I wasn't able to actually edit the notes today because K-12 was too slow. So I'm just asking everyone to take pictures so that once the notes are ready, you can fill it out really fast today. So 30 seconds, everyone, give me a green check once you have your notes filled out. Oh, that could be Nichelle. Seconds, everyone. Green checks once you have a picture. All right, let's keep on going. So taking a look at classification of matter here again. If it's pure, right, it means it cannot be broken down physically, right? So this is all about physical. So physically, this one cannot be broken down. This one can be broken down physically. Mixtures. Pure substances, if they cannot be broken down chemically, that makes it an element. If it can, that makes it a compound. Mixtures, if they look the same throughout, they're homogeneous. If they look different throughout, they are heterogeneous. Heterogeneous. I know, Aria explained that the notes, I wasn't able to edit them today because K-12 was being too slow for me this morning. So I'm just asking you to take pictures. And then once the notes open, you'll be able to complete them. Okay, so I'm gonna try to do it really slowly through K-12, and then hopefully they'll be ready by 10. Thank you. All right, so let's go ahead and practice this together. All right, so let's take a look at pizza. Can pizza be separated physically? Yes or no? Tell me in the chat box. Can pizza be separated physically? Yes or no? Think about the pepperoni, the crust, the cheese. Yeah, definitely. So this is gonna actually make it a mixture. Right, so this one is a mixture. So it tells me to go to step 2. So I know it's a mixture, go to step 2, and we're going to figure out what type of mixture. Is the mixture uniform? Does it look the same throughout? Does the crust of a pizza look the same as the center of the pizza, look the same as the top of the pizza, look the same as the bottom of the pizza? No, it looks different. The crust looks very different from the center. So if that's the case, then this would be a heterogeneous mixture. So I'm going to mark this as B. This is a heterogeneous mixture. Go ahead, give me a thumbs up if that makes sense. Heterogeneous mixture. Thumbs up if that makes sense. Cool. All right, let's go ahead and try titanium. So titanium, which is the atom Ti, can that be separated physically? Yes or no? Titanium is the atom Ti, right, on the periodic table. So can that be separated physically? No, titanium is a pure substance, right? It's just titanium. And so we're going to go to step number 3 and figure out, is it a pure compound or a pure element? So can this be separated chemically? If it's just the single atom, Ti, can that be separated chemically? Yes, that makes it a compound. No, that makes it an element. What do you think? Yes or no? It's just a single atom right here. No, it cannot. So this would actually make it a pure element. So I'm going to mark this as D. This one right here is a pure element. Pure element. All right, go ahead and try salt water for me. What do you think salt water is? Go through these steps, and then I'm going to go ahead and give you your polling tools and tell me, what do you think salt water is? Is it A, homogeneous mixture, B, heterogeneous mixture, C, a pure compound, or D, a pure element? Go ahead, use your polling tools, use your polling tools. What do you think this is? Go through the steps, go through the steps. Think about salt water. We practiced this several times today. Practiced it several times today. Looking good. I got an answer from Vanessa. I see an answer from David, from Hallie, from Jarrett, from Alex. All right. Looking good. All right, looks like we are kind of split right now. Looks like we're split between either it is a homogeneous mixture or a pure compound. But let's go ahead and take a look at this. Salt water, can it be separated physically? Think about the salt water in the pasta pot. We talked about what can we do? Can it be separated physically? Yes, it can. We can actually separate it using evaporation, right? So salt water can physically be separated with evaporation. Evaporating the water away from the salt, right? So that is a physical process. So in that case, we go to step 2. Does it look uniform or the same throughout? Yes or no? Tell me in the chat box. Does the top of a glass of salt water seem the same as the bottom, seem the same as the center? Yes, so this is actually a homogeneous mixture, or what we could call a solution. So this one, the correct answer is A. All right, go ahead. I know that we were a little bit confused about that, so go ahead and give me a video game controller if that correction makes sense. That's why we're doing this together, because mistakes help us to grow, help us to learn. Perfect. Now, last one, sugar. Sugar is made up of 6 carbon atoms bonded to 12 hydrogen atoms bonded to 6 oxygen atoms. What do you think this one is? If you understand process of elimination, you can probably figure it out. Go ahead. Let me get your polling tools. Give me your polling tools. What do you guys think this is? All right. Keep in mind, we already used the letter D. So again, if we're thinking about process of elimination. All right, yes, it looks like we are choosing letter C for the most part, and that is correct. So letter C is the correct answer, all right, and we can go through that and show that to you. So can it be separated physically? Sugar, if all of these atoms are bonded together, can you physically separate those from each other? If you took a single crystal of sugar, could you physically separate it into carbon, hydrogen, and oxygen? You can physically separate the carbon from sugar, just like with your hands. No, you can't physically separate the carbon, hydrogen, and oxygen. Vanessa's like, I'm just that much of a boss. So in that case, it must be pure. And in this case, is it a pure compound or a pure element? Think about it. It's made up of many different atoms. So does that make it a compound or an element? It's made up of many different atoms bonded together. Would that make it? Yes, it would go boom. Yes, this would be a compound. So this is letter C, a pure compound. Perfect. All right, everyone. So we already actually talked a lot about this, right? We talked about how meatballs are heterogeneous mixtures. We talked about how the salt water is a homogeneous mixture. Right. If you think about the different compounds, right? So there's things like salt and sugar, right? As well as the water. Those are all compounds, pure compounds. I know it does look good, right? All right, sorry. So the last thing I need to talk about really quickly, I know I'm out of time here, but energy, remember, is the ability to cause change, move matter, and do work. Matter is the world around us, right? So essentially matter is the stuff and energy is what we do with the stuff. Okay, so matter and energy interact. That will be the answer to number 3 in your notes. Go ahead, give me a green check once you have a picture of that or you've written it down. But this will be number 3 in your notes once your notes open. And for example, photosynthesis is where plants are the matter and they use light energy in order to convert water and carbon dioxide into sugar and oxygen. So we can see how matter is the stuff and light is what we do with that stuff. All right, so again, green checks for number 3. I'm going to go ahead and give you 15 more seconds. Give me green checks once you have number 3. You've taken a picture of it and you're ready to move on. All right, I'll come back to it if I need to. And so the last thing I need to talk about is that matter and energy are conserved. Do you guys remember what's another word for conserved? Starts with an S. We talked about this last quarter if you were with me last quarter, or if you just know the word conserve. Think about conservation efforts around the world. Right, we're trying to conserve forests, conserve certain species of animals. What does the word conserve mean? Yes, to save. So conservation of matter and energy means that matter and energy are saved. They don't magically appear. They don't magically disappear. So matter and energy are both conserved. So matter can change forms, right? It can go from hydrogen and oxygen and turn into water, but the actual quantity, the amount of atoms, the amount of mass does not change. There's no increase and no decrease in the quantity of matter. It stays the same. It's saved. It is conserved. Same thing with energy. Energy is never produced, never discarded, never created, never destroyed, but it can change forms, right? Think about electrical energy can turn into light energy from a light bulb and thermal energy from a light bulb, the heat from the light bulb. So the total quantity of both matter and energy in our universe is fixed. It is the same, always has been, always will be. Go ahead, give me a thumbs up, everyone, if that makes sense. Thumbs up, everyone, if that makes sense. Perfect. And then you have 30 seconds green checks once you have number 4 saved. You've taken a picture. And then I will give you your end of class word. Thanks for being patient with me as we've been figuring out the Perfect. All right, everyone. So we talked about physical chemical properties today. We talked about how to classify matter. We talked about matter and energy and how they interact. So let's go ahead and, sorry, I'm just going to go ahead and stop our recording. Again, make sure that once the notes are ready, again, I'm sorry, I'll try to get them ready as soon as K-12 lets me to get them ready, but make sure you get them done and submitted. All right.